So today we are going to start with polygons. So polygons are closed figures. They are closed figures made up of line segments. So circle is also a closed figure, but it's not a polygon because it's not made up of a line segment. So it has to be a closed figure made up of line segment. So now the smallest polygon will be obviously a triangle. Then after triangle, uh, so triangle is made up of three sides, and then after triangle we have a quadrilateral, and then so we have to do um, quadrilaterals in detail. So in polygons we have to do quadrilaterals, and in quadrilaterals are those polygons which are made up of four sides. Quad means fours, so quadrilaterals are the polygons which are made up of four sides. And then in quadrilaterals we have to do parallelograms and trapezoids, and there is kites, but we don't have to do anything about kites. So we'll see what are parallelograms, what are trapezoids, what are kites, and then under parallelograms there will be rectangle, square, rhombus. So first of all, what do you understand by parallelogram?
Like slanted.
Two lines are parallel and others are slanted. So you are saying like this.
Mm, yeah.
What about something like this?
Um, like a rectangle.
Sorry?
A rectangle.
It is a rectangle, but is it a parallelogram?
No.
No, that's not
Wait.
correct. Wait.
It is. It is.
See, first we should understand the um, meaning of parallelogram. Then we parallelogram will be that closed figure in which there will be two pairs of parallel sides. Okay, so I'm gonna write
Mm-hmm.
that here: two pairs of parallel sides. Okay, now in parallelograms we have two types of parallelograms that we have to do. First one is rectangle.
Mm-hmm.
So rectangle is also a parallelogram. Okay, so first one is rectangle and the other one is rhombus.
Okay.
Okay, now what's a rectangle? A rectangle is a parallelogram in which all the angles are right angles. Okay, so rectangle is, so I'm going to use this notation to write parallelogram. I'll draw two parallel lines raised to gm. This is a shorthand notation. So rectangle is a parallelogram in which all four angles are right angles. All angles are right angles. And so Tanvi, do you know about rhombus? How does a rhombus look like?
The rhombus. Yeah. It's. Alright. The two sides are. It's. It's like, isn't it? Like, so all sides of the same length, right?
All sides will be of same length. So a rhombus is a parallelogram. It is, again, it's a parallelogram with all sides congruent. All sides congruent. Then what's a square? square. So what's a square? Now square comes under rhombus.
Okay.
Square is a rhombus in which all angles are right angles. So square, it is a rhombus with all four angles as right angles, with all
Mm.
angles as right angles. Okay,
Yeah.
now you know everything. So okay, so majorly we will focus on rectangle, square and trapezoid. What's a trapezoid, Tanveer? In trapezoid,
The trapezoid is when you have
in trapezoid
like
it
you
looks,
like you have the two are parallel and then the other sides are slanted.
yes, so that's the definition of trapezoid. In trapezoid there will be only one pair of parallel sides. In parallelogram we had two pairs of parallel sides. In trapezoids we'll have one pair of parallel sides. Okay, so we will write this here, one pair of parallel sides. And kites are not that important. Well, kites are figures which look like this. It's a very bad kite. You must have seen a kite, right?
Yeah.
I mean a real kite. You know, this is how it looks, and its definition is that here you'll have two pairs of adjacent sides congruent. So this side and this side, they are both adjacent and they are congruent, and this side and this side, they are both adjacent and they are congruent. But kites are not important, we won't be doing kites. So these are all the polygons, not all the polygons, but the ones that we want to focus on: rectangle, rhombus, squares and any parallelogram. Okay, Tanvi, do you have any doubt in this?
No, that makes sense.
Okay, now we want to do some properties of these parallelograms, Tanvir. Okay, so I'm gonna draw all the four uh, parallelograms that we have to do, and we will do some properties about their diagonals, how the diagonals bisect each other, and will the diagonals be equal. So all the properties. Okay, so rectangle, then a square. Where's the square? And we need a trapezoid, and we need a rhombus. Okay, so Tanvir, can you tell me about the diagonals of a parallelogram?
Diagonals?
Mm-hmm. Will the diagonals be equal in a parallelogram?
Yeah.
Yeah, are you sure?
Wait, uh, in length, I think so. Yeah.
Whoops, wait a second.
Yeah.
Uh, okay. So we will be doing three properties of diagonals, Tanvir. Whether the diagonals will be congruent, whether they will bisect each other, or will they bisect at 90 degrees. Okay, these three properties we have to do for all the three, for all the 5 6 parallelograms. Okay,
Yeah.
so I'm gonna write here, I'm gonna write diagonals equal, here they bisect each other or not, and here I'm going to write whether they'll bisect at 90 degrees or not. Okay, so first let's talk about a parallelogram, Tanveer. I'm going to draw two diagonals for this parallelogram, this and this. First, do you think the diagonals of a parallelogram will be equal? Will they be congruent?
Say it again.
Uh, so I've drawn a parallelogram and I've drawn two diagonals of that
Yeah.
parallelogram. Do you
Yeah, I
think
think it should be.
they should be equal for any parallelogram?
Yeah.
Okay, now if I draw this parallelogram, this is also a parallelogram. Do you think that the diagonals will be equal in this one?
Yeah.
Really? Wait, then let me draw one more. Uh, okay, what do you think about this parallelogram? Will the diagonals be equal? This is also a parallelogram, right?
Yeah.
Diagonals are equal in this one. The red colored lines, the two lines.
Is it equal?
What do you think?
Um. Uh, hmm, I don't know.
The red colored lines, do they look equal? Here in this one.
Yeah.
They look equal
Wait, where's the red color line? In the first one, right?
in this one. In this one.
Oh yeah. No.
No, right? Two I've drawn. Do you know what's a diagonal is, right?
Hmm.
Right? So I've drawn two diagonals. Do they look equal?
No.
No. So in a parallelogram, it's not necessary that the diagonals will be equal. Okay? So here we will draw a cross. Diagonals will not be equal. Second thing is, will the diagonals bisect each other? So by bisecting we mean,
Yeah.
yeah, the diagonals will bisect each other. So this length will be equal to this and this one will be equal to this. So diagonals will bisect each other. Will they bisect at
Hmm.
90 degrees? That means, would it be correct to say that this angle will be 90?
Um. Yeah. No. Actually, no.
No.
I
So
don't think so.
if you ever find yourself confused, then draw a very slim parallelogram. Like here I've drawn a very slim parallelogram, and here you will get answers to everything. So first of all, diagonals are not equal, but they will bisect each other. But the angle, this angle is not 90 degrees, so they do not bisect at 90 degrees. So they do not bisect at 90 degrees. Now let's come to rectangle, Tanveer. Now for rectangle, do you think diagonals will be equal?
Yeah.
In
Um.
rectangles,
Yeah. Yeah. I think so. Yeah. Definitely.
definitely. Because here, if you can actually prove it by Pythagorean theorem, because this diagonal will be equal to the sum of the length, like the squares of the length and the width, and this one will be also equal to the sum of the square of the length and the width. Okay, so diagonals are gonna be equal. Will they bisect each other?
Will they bisect each other? Yeah.
Yes. Okay, and will they bisect at 90 degrees?
Will they bisect at 90 degrees? Um,
Does it
yeah.
does it
Yeah.
look like a 90 degrees angle?
Mm, actually, I think so though. Yeah.
So draw a very slim rectangle. Let's draw a very slim rectangle. Then you
Oh
will
yeah. No. No.
wait. Let's do this. So I'm gonna make it very like slim. Okay. This is also this is still a rectangle, and draw two diagonals for this. So if a result follows for one rectangle, it should follow for every type of rectangle. Damn it.
Yep. Got it.
Now, do you think they are bisecting at 90 degrees? What I mean by that is this angle. Is this 90 degrees? No. So they will not,
Mm.
they will bisect, they are gonna bisect, but not at 90 degrees. So we put a cross here. Now let's come to square, the most interesting parallelogram. Here is a square. So now one by one, Tanvir, you will tell me, will the diagonals be equal? Will they bisect? And if
I
they,
think yes, for
yes for all, yes. They are gonna be equal, they will bisect, and at 90 degrees as well. Now after square, let's do for a rhombus. This is a rhombus.
mm,
Rhombus is a parallelogram in which all four sides are congruent. So this,
yeah.
this, this, they are all congruent, but they're slanted.
Uh,
So first the diagonals. So see Tanvir, if for parallelogram, if for a parallelogram the diagonals are equal, then it will, well actually yeah, parallelogram diagonals are not equal, so we cannot say this for all of them. What I wanted to say was that if they are bisecting for a parallelogram, then they will bisect for every type of parallelogram. Like we did it for a general parallelogram, right? This is the most general parallelogram, and we got that the diagonals are gonna bisect. So they will bisect for every single type of parallelogram. That's why we have a right for each one of them. Right, so here as well the diagonals will bisect. Will they be equal? Will the diagonals be of same length? Will they be congruent?
will they be conclude? I think so.
Are you sure?
Will they, actually, no. If you draw a really slim one,
They will not.
yeah, I think, yeah, I don't think they will.
Yes, in rhombus they will be not equal. They will not be congruent, but they will bisect each other, and they will bisect at 90 degrees. Okay, so here we put a tick. Okay, and then finally we have trapezoid. Well, trapezoid is not a parallelogram, it's a different figure, and here we don't have to do the properties of diagonals. Okay, now one by one, Tanvir, we will do the formulas of areas for each one of them.
Yeah.
Okay, so What's the area of a parallelogram in general?
The area, the parallel area. I forgot the formula.
Okay, do you know the formula for rectangle? Area of a rectangle? Area of a rectangle, Tanveer?
Um, it's just base times height, right?
Base times height. Yes, exactly. Base times height, that's it. Base times height. And the base can be any side. So if this is base, then this will become height, the perpendicular distance. And if you're taking this length as base, then this would become height. Okay. Now
Mm.
this same formula applies to all the figures except trapezoid. Base times height in all different types of parallelograms. So it is going to be base times height for this as well. Here height is always the perpendicular distance between the two parallel sides. See, if this is the base, now if this is the base, then height is going to be this perpendicular distance.
Mm.
So this has to be perpendicular. So the length of this green dotted line, that will be the height. Okay. Then for square as well, it's the same formula, base times height. But for square, since the base and the height will be same, because this length is, because all four lengths are same in squares, right? So let's say this is S, so this will be S, this is the S. So base times height is going to be S times S, or S square. So area of
Mm.
a square is square of the side. Okay. Same formula will be for rhombus. So if this is the base and the height will be this perpendicular distance. So this is the base, this is the height. Area is going to be base times height. But you just have to be clear with one thing: what is the base, what is the height. You could even take this side as your base, Tanveer, then the height will be like this length. And for trapezoid, it's slightly different. Do you know the area of a trapezoid, Tanveer?
Um, no.
For trapezoid, the definition was that it has one pair of parallel sides. Let's say these two are parallel pairs. Mm, and
Mm-hmm.
let's say that this is B1 and this is B2, base 1 and base 2. So what we do is we find out the average of these two bases. So B1 plus B2 divided by 2, that will be the average. See, ultimately the formula is still the same. It is base times height. It is still the same. But here we, instead of one base, we have two bases. So we take their
Mm.
average, B1 plus B2 over 2 times the height. Height will be the perpendicular distance between these two bases. This is the height.
Okay, got it.
That's the formula for area of a trapezoid. Okay, now we will do one more concept of polygons, Tanveer, and then polygons will be done and dusted. So the next concept is regular polygons, and this is really important. Regular polygons. What do you understand? Do you have you heard of this term before, Tanveer? Regular polygons.
Mm, yeah, it's just wait no. Is it just a square and like squares and rectangles?
Well, not rectangle, but square. Yes, it is a regular polygon. in general, what do we mean by regular polygon? So regular means, this word regular means that all the sides will be equal. So if I talk about the smallest polygon, which is a triangle, so I could have a triangle like this. Wait, I could have a triangle like this. Wait, it, yeah. Or I could have a triangle like this, in which all the sides are equal. See, then we in the first one, all the sides are not equal, right? Actually, let me draw a very weird triangle. See, would you say all the sides are equal in this triangle?
Um,
Are all the sides
mm,
equal?
no.
No. So this is called irregular triangle. And if I draw an equilateral triangle, this one, let's say all three sides are equal, this is equal, this is, all three sides are equal, this is actually an equilateral triangle. So in this one we say that this is a regular polygon, a regular triangle. Okay, second one, Tanvi, so this was for triangle. Then the next is quadrilateral. So first we'll draw a irregular quadrilateral. Okay, irregular. So let's say something like this. Okay, this is an irregular quadrilateral. And what will be a regular quadrilateral? It will be a square. After quadrilaterals, what's the next polygon, Tanveer? The one with 5 sides?
A pentagon.
A pentagon. Okay, so in pentagon as well, so okay, this side left ones are all irregular polygons, and on the right side we have all the regular polygons. Irregular. Okay, the next we'll do one more, pentagon. A pentagon, if I draw a regular pentagon, it's gonna look like this. Oh, okay. Yeah, not bad. Okay, so all the sides are equal, and an irregular one will be well, that's a very random one. I hope the concept is clear, Tanveer. What's the difference between irregular polygon and regular polygon?
Yeah.
Now what we haven't even started yet. What we have to do about regular polygons is we should be able to find out the measurement of each angle of the regular polygon. Now one thing is that each angle of the regular polygon will measure same, so all the angles will be also congruent. All the angles are gonna be congruent. Okay, and we should be able to find out the measurement of each angle, and for that we use a formula. That formula is given by, it is given by n minus 2 times 180 divided by n. This formula gives you the measurement of each angle, measure of each angle of a regular polygon.
Mm.
Each interior angle. Okay, each interior angle. Okay, so regular polygon. Okay, so let's use this formula, Tanvi, to find out the measurement of each angle of a pentagon. For a pentagon, can you find out the measurement of each angle? So n is what?
Pentagon. Okay, I'll be.
What's the
It would
n?
be. Wait 1 second.
Tanvir, what's the n in this formula?
Wait 1 second. I'm trying to calculate.
Wait. Your mic. I think your mic is far from your mouth.
Wait, I'm trying to calculate something. 540/3.
504. Yeah,
So
n is the number of sides.
so yeah.
So 108. 540. Wait, no. 540 over 5,
No,
not 3.
over 5.
Yeah, over 5. That's gonna be 108. So each angle of this pentagon is going to be 108. Each one of these. But in the irregular one, we cannot say that. And also, Tanvir, the numerator of this formula, only this part, the numerator, this gives you the sum of all the angles. Sum of all the angles, which is again really important. Sum of all the angles. So for a quadrilateral, and the sum formula works for any type of polygon, whether it's irregular or regular. Okay, I'll just make this one very clear. Sum of all the angles of any polygon. It can be regular or it can be irregular. The sum is given by n minus 2 times 180. Okay, this will work for even an irregular polygon. So can you find out the sum of all the angles of a quadrilateral? Just sum. Let's say we have this quadrilateral. Can you find out the sum of all the angles? Use this formula.
Okay. 2 times 180. It's 360.
360. Yes. So sum of all the angles of a quadrilateral will be 360, and for a regular quadrilateral, if you want to find out the measurement of each angle, so we divide 360 by 4, and that's how we get 90. So each angle will be 90. And for triangle, you'll get 180. 180 divided by 3, and each angle will be 60. So each of these will be 60. Okay, Tanvir, are we good with regular
Yeah.
polygons? This I just want you to remember this formula. This is really important from SAT's point of view. N minus 2. One of my students, she got a question based on this concept, and she mistakenly remembered the formula n minus 1 times 180 over n, and she solved the question using this formula n minus 1, and she got the wrong answer. And unfortunately, the wrong answer was also there in one of the answer choices. So you don't, the moral of the story is never forget this formula, n minus 2 times 180 over n. Okay.